Okay. Apologies for my late start. Just needs patience. So welcome back to from St. Benedict's Day for capital budgeting. Are there any questions before I dive into the capital budgeting stuff for today? Are there any questions on anything we covered on Monday? Yes, sir.
Can you go over coefficients and variance? I mean, like math, or the math part of it.
Can I go through the math part of coefficients of variance?
Yeah. Like just briefly, like formula.
So formula-wise,
You don't need to go
we're gonna go into some actual. I don't know how to do it any other way. Let me find. Just switch this over. Okay, so your question, so the question that came up was, can we talk through this standard deviation and coefficient or standard deviation and variance analysis and try and understand kind of how to calculate that? So I think I'm on the right track. And if I'm not,
well, okay, so I was going through the midterm and I did, and per your advice, like make it out the formula on a spreadsheet and then put standard deviation on top that it gave me, and then the rate of return or R hat at the bottom. And it gave me an answer, and I put the answer that I got and also matched what was possible, and it gave me a completely different answer.
okay. So I'll walk you through it here, but if you've got the problem and you email it to me, I will walk through it for the entire class on Monday, so that we've got it squared away. But let me walk through an example of a typical problem, which, by the way, I believe is also potentially on the midterm. So you've got a investment A, and it's got a potential return, and so it's got a potential return of 20%, and there's a probability of 0.5 that that's going to happen. It's got a potential return of 10%, there's a probability of 0.4 that that's going to happen, and it's got a potential return of negative 10%, and there's a probability of 0.1 that that's going to happen. So you see that the sum of these is equal to 1, or 100%, the probability, and this is the expected return. Or this is a potential return. The expected return is no more complex as multiplying the potential return by the probability that that potential return happens. So 20% times 0.5 is 10%. You sum the total up, and in this particular case, the expected return is 13%. Because you've got a 50% chance that you're going to get 20%, a 40% chance you're going to get 10%, a 10% chance you're going to get negative 10%. And so you just kind of run through that math and you get an expected return of 13%. So the question then asks, compute the standard deviation. And again, this is one of the midterm problems. So if it ends up showing up on your midterm before you turn it in, you've now gotten the answer. So you go, okay, here's the payoffs. Here's the payoffs. So we've got the payoff of, comes straight down from here, so they're linked. These are these. The expected return is what we calculated here. So that goes in this column. And there's a couple of spots in the book where it actually just spells this out for you. And while the book is not the world's finest textbook, it is one of the cheapest finance textbooks you can find. And it has this nifty computer side where you don't have to carry a book around with you all the time, just to pull it up on your laptop. And it does good enough on how do I do the math. So there's a table in there that shows an example, and I just recommend you take that table and just fill it in with the new numbers. So you got the expected return of 13%. The deviation is just subtracting this from this. So now it's 7%, 3%, or minus 3%, minus 23%. That's the deviation between the potential return and the expected return. Then when you get to the next column, you just square the deviation. And so the Excel formula to square is just that little caret. So you square it, and you get these totals. Now these totals, because we're looking for essentially standard deviation on a normal distribution, you don't have negatives. So the squaring gets rid of your negatives. And essentially we're just looking at the total deviation, whether it's positive deviation or negative deviation. Then you go back and you multiply by these probabilities again. So you do that, you come up with this variance. You sum the variance, and that gives you the total variance for that distribution. So all that is multiplying those, sum that together, and then to get the standard deviation, which is the square root of that, you just take the square root. It's expressed in terms of a percentage because your payoff and expected return are a percentage. So generally your standard deviation is going to be expressed in the same type of units as your underlying. And so the standard deviation in this particular case is 9%. And so this is a pretty typical methodology by which to walk through and calculate the various components of expected return, deviation, probability, the variance, and standard deviation. And if you're missing one component of this, essentially you've got all the other pieces, and it then becomes algebra. What I'm trying to solve for x. So if you're trying to solve for the variance and you're given the standard deviation, you're going to take, instead of here, you're taking the square root, you're going to square this, and it's going to get you this number. And then you can reverse engineer this entire thing back, essentially using algebraic techniques. And so this is a typical try and find a standard deviation question. It is one that's on the midterm. It's one of the potential 700 some questions that are on the midterm. This is one of them. Any questions on this? Any other midterm related questions? Any other questions at all before I do capital budgeting? If you guys get through the midterm, when you get through the midterm, if you got questions on midterm problems and you're going, look, this thing just befuddled the snot out of me, I don't know how to do it. Either, as some of you have done, take a picture of that question or write that question down, email it to me. I will cover them in class if you'd like, or we could cover them one-on-one. But if you're confused, you don't have to just go, well, screw it, I didn't get it right. You can actually just let me know, hey, this one doesn't make sense. I've got this, here's the question, can we walk through it together, and I'll happily do it. I've done that for a number of years already, one-on-one, and I can do it here in class as well. So don't hesitate if you're getting hung up on something on the midterm, make your best guess, get an answer in, but also take a snapshot or a screenshot of that particular question. We can walk through it together in class, or we can walk through it one-on-one. Anything else before I go into today? Okay. So this is basically where we left off on Monday. We left off with calculating net present value of a potential project. And we said, hey, if the net present value is greater than 0, and arguably it's equal to 0, we accept the project and we do that project. If the projects are mutually exclusive, meaning you can only do one or the other, you choose the one with the highest net present value. Because net present value is equal to what? What concept does net present value equal? Or what does net present value mean?
Economic profit.
Economic profit. So if something's got a positive net present value, it means you've got economic profit. Not just accounting profit, but economic profit, which means you're getting a higher rate of return than the underlying risk requires. So you're creating wealth. And so you're going to choose the highest. And if both of them, if they're not mutually exclusive, and they both have positive net present values, which ones do you choose? Both. And if they both have negative net present value, which one do you choose? Neither. So, or neither. So that's the basic net present value approach. We walked through calculating net present value for project S. Take my word for it that if we did the same process for project L, you're going to get a net present value of $108.67. Does anybody want me to go back and take a look at how we calculated net present value for project S? We're good. Okay. So projects S and L are mutually exclusive. We accept project S because the net present value is higher. So if you can only do one or the other, you take the one with the larger net present value. If they're independent, you take both because the net present value of both is greater than 0. Under what circumstances do you think, we talked through a couple of them, under what circumstances do you think projects would be mutually exclusive? When do projects become mutually exclusive? Give me some examples of mutually exclusive projects.
When they're both really big and you have a budget.
Yep, when they're both really big and you have a finite amount of resources to finance them. So if you've got two projects, each one's going to cost you $1 million of cash up front. You only have $1 million. You can only do one. They become mutually exclusive by virtue of resources. What other circumstances? Yes, sir.
Was this the same thing you're talking about with the bear thing?
Yes.
Like rebuilding and buy another building?
Correct.
So you're limited by time and resources other than just money.
Yep. Anytime you're limited by time or resources other than money, it's an either or type question. I can either renovate Barron or I could tear it down and build a new one. I can't do both because I can't tear it down and renovate it. So that becomes mutually exclusive. Independent would mean that they're not mutually exclusive and you could do both. Internal rate of return. And this again is a Excel function. So NPV is an Excel function, equal NPV. IRR is an Excel function, equal IRR. Internal rate of return is a rate of return that will be earned if a project is purchased and held for its entire life, and the IRR is calculated, and there's some interesting components to this, and we'll talk about IRR versus modified internal rate of return. IRR assumes that the cash flows are reinvested in a project with the same IRR as the one that generated it. Follow? So if the project is generating an internal rate of return of 18%, it assumes that for IRR calculations, that all the cash flows, the positive cash flows, are also being reinvested at 18%. So a project, the IRR decision rule essentially says, look, if I've got a required rate of return of 12% and the IRR on this project is 18%, we do this project. Because the required rate of return for the firm is lower than the rate of return that the project is going to generate. Why might that be a problem? Under what circumstances might that be a problem? What are we ignoring?
The, whether or not it actually gets that actual
Which is, we call what?
rate.
Risk. So what we're ignoring here is you've got the firm's required rate of return, but we're not really looking at the project-specific risk associated with it. So for instance, buying lottery tickets might have a relatively high IRR, but you're not accounting for the risk. Actually, it wouldn't because the probability is low. But if you're going to start up, let's say we're back 2012, and we're in the state of Washington, and all of a sudden there's this big election referendum. So I-502, all of a sudden we make cannabis legal. You know, I'm getting in the weed business because there's a lot of money to be made in that. Even though you right now have a sandwich shop in downtown Olympia. So your sandwich shop is relatively low risk, right? You're well established, you're kind of rolling right along, you're doing okay. And then you decide you're going to open up a 502 store next door. And you're going to call it Paul's Weed and Feed. And so when you got the weed and feed, and you go, well, my required rate of return is 12% because I got this store and I've kind of been cranking along and 12% seems good to me. What if you failed to account for the fact that you're looking at a brand new business? Regulations are all new. You don't know what the demand's going to be. You don't know any of that kind of stuff. And so what IRR, when you look at this decision rule, the assumption behind that decision rule is that the project that you're evaluating is going to be comparable to the overall firm risk. And if it's different, you're changing the risk profile of the firm and you're changing the risk profile of the project. And so if you just use this IRR decision rule as it sits and you've got your feed and you decide to add the weed, it might not actually be equivalent. You might have a different risk profile and it might change the risk profile and your required rate of return for the firm. When you're trying to find IRR, the interesting thing to note is IRR is the point at which the net present value equals 0. So whatever the return is that makes the net present value equals 0 becomes the IRR. These two pieces of the equation are related. So essentially, when we looked at Project S, we said, okay, Project S had a positive net present value based upon of $167, I think, if I recall right, based upon the required rate of return. Now we're trying to solve for required rate of return. There's an IRR calculation in Excel which allows you to do that, which essentially says what's the IRR of this cash flow stream. So you're going to hit equals IRR, load this cash flow stream in, close parens, and it's going to tell you what the internal rate of return is. So here's how to do it in Excel. Enter the cash flow sequentially into a cash flow register, essentially a series of cash flows. Then use the IRR function. It's really easy stuff. For Project S, when you do that, and you're welcome to do it at your desktops. I see some of you are intently doing it right now. If you do it for Project S, you're going to find the IRR is 13.1%. If you do it for Project L, you'll find the IRR is 11.4%. That makes sense, right? Because the IRR here is higher than here. The net present value is higher here than it was for here. Both of them have positive net present values, and both of them, the required rate of return when you calculate its net present value is 10%. So the IRR should be higher than 10% if the net present value is positive. Is there anybody having trouble for those of you who are choosing to do it, getting these answers in Excel. Straightforward stuff. So the rationale for the IRR method. If a project's rate of return is greater than the firm's required rate of return, then some return is left to boost stockholder return. Essentially, there's return left over that's generating economic wealth or economic profit. The issue with IRR is it's not accounting for, and nor does NPV really account for project-specific risk. We're looking at it in light of the firm. And we're assuming that the beta associated with the project is equal to the beta associated with the firm. And that is not always the case. So that's just something to keep in mind as you start doing capital budgeting, because if you take on a large project that's got a higher risk profile, the numbers might tell you you're utilizing the existing required rate of return, that project is good to go. Or really, you need to be looking at it post-acquisition or post-project. What's the required rate of return based upon your capital structure and your risk profile, and then analyze in light of that. And that's when we get into chapters 14, 15, 16. That's actually where we're going to be taking this analysis. So in this particular case, if Project S and Project L are independent, we're going to do what?
Project S.
You're going to pick Project S. Why?
Because it has a higher rate of return.
What are you going to do with Project L?
You are going to put it back, and maybe if you have money later, if you want to.
So if they're independent, what are you going to do? Take them both. If you've got the resources, if they're independent and you have the resources to do both, do it. The math says do it. If they're exclusive and you can't do both, then which one do you choose? You choose X. Why? The IRR is higher, the net present value is higher. This is looking at based on IRR, but you're going to get the same answer. The IRR is higher, therefore you take S. There's going to be times, I can't remember if I put a slide in this or not, but since I'm talking about it, I'm going to talk about it now. There's going to be times when the NPV is higher on project, let's say the NPV is higher on project L, it's 300, than it is on project S. Under what circumstances do you think that might happen, where the NPV is higher on a project, on one project if you're looking at NPV, but if you're looking at an IRR, the IRR is lower? It's not going to be risk, it's going to be, but you're on the right track. If you have a project that's $100 and you have a project that's $10 million, if they're mutually exclusive, you can have a situation under which the $1 million project or $10 million project creates a much larger net present value, right? Because it's got a big number. It might be, if you look at this, it might have a required rate of return is 10, and its return might be 11.4. And it's going to generate for you a net present value of $140,000. The other project is mutually exclusive. It costs you $100. It's got an IRR of 13%, and it's going to generate for you an NPV of 14 bucks. Which one do you choose? Do you choose the project with the bigger NPV, or do you choose the project with the higher IRR?
The NPV.
Why?
More money for you.
More money for you.
That's the whole point.
That's the whole point.
If you're better.
So if you've got a choice, generally a finance person will tell you, if you have a choice between two projects, take the one with a higher MPV, even if it's got a lower IRR, because our job is to create economic profit. And arguably, it should be of lower risk, so it's got a better probability of that economic profit. IRR is easier for people to understand. When you're walking up to somebody, you go, look, I got to get a required return of 10%, and this project gives me 13.1%. Should I do it or not? Most folks, including like even psychology majors, will be able to figure out that 10% is less than 13%, and that's good. And yeah, go ahead and do that. But if you walk up to a psychology major and go, I got a project that's got a net present value of $164.12, and I just gave $3,000 from you today to be able to make that happen, are they going to understand what you're talking about? No. So in a lot of cases, when you're dealing with finance concepts, where things like net present value might be the better way to answer a question, a lot of times when we're communicating with non-financial stakeholders, we are responsible for translating our language into their language. And IRR does that because it makes it very simple. Is it higher or lower? It's a percentage. Everybody kind of understands percentages. I get 13% on my money versus 10% on my money. That's a good answer. Let's go. And net present value is a financially more robust, but a little bit more arcane method to be able to measure. So here's the net present value profiles. Essentially, when you say, okay, what's my required rate of return? That's this discount rate. So at various required rates of return, you have different net present values. If the net present value, or if the required rate of return is 0, so there's no discount at all, we looked at on last Monday and said, hey, or on Monday we said, hey, Project L actually is the best deal if there's no discount because our net profit is higher, right? From an accounting perspective, our net profit on this is going to be $1,100. Our net profit on this is going to be $800. But because money has a time value, we want to make sure we account for the fact that money has a time value. So then we start discounting. So at a 5% discount rate, L is still better because those out year higher cash flows aren't discounted as much. At 10%, which is the kind of the model that we use to be able to walk through this, you see it's flips over and S becomes better. At 15%, they're both negative. And that makes sense, right? Because when we just did the IRR calculation, the IRR of 1 was 11, the IRR of 1 was 13. And so once you get to 15, they both should be negative. And at 20%, they're both even more negative. You can graph this out because it's linear and be able to identify, if you graph these out, where the IRR is based upon where it crosses over to 0. Just like that. And you can see that at this point, at 8.1%, if your discount rate is 8.1%, you're indifferent between the two. At 8.1%, the net present value is going to be equal. Any questions on this concept? It's pretty basic math. Okay. There's going to be 2 reasons why you see different slopes on a net present value line, on a net present value profile. The first one is you've got the size of the project. So smaller projects tend to be favored. High R favors small projects. High returns favor small projects. Timing differences. Projects with faster payback. So earlier, higher cash flows. tend to give higher net present values. And it's only going to be, as we saw in Project S and Project L, in those out years where that discount rate really begins to have a significant amount of impact on the net present value today. There's a few reinvestment rate assumptions, and these are important because in many cases, you can't reinvest at those rates. These projects, especially if they're positive net present value projects or higher IRR projects that you require rate of return, these projects aren't just out there lying around for you to invest in. And so as the cash flow starts coming off that project, so you put in your $3,000 and then you get to the first year and you get your $1,100 back in the first year, the assumption is that you're going to be able to reinvest that at that same IRR. The reality is you're going to have to look for another project to reinvest that money in, or you're going to pay it out as dividends, or you're going to hold it as cash. So net present value assumes that you're reinvesting it at your required rate of return. IRR assumes you're reinvesting it at the IRR rate. Which one is more conservative? NPV, why? It's reinvesting at a lower rate. And essentially, you're saying, look, if I can't reinvest this money at least my required rate of return, I'm then likely to dividend it out to shareholders. I'm going to give it back to the investor. On IRR, it assumes you're reinvesting at that IRR rate. So in this one particular case, if you look at Project S and the IRR is 13.1%, the required return is 10. NPV assumes you're reinvesting it at 10. It's paying out 13.1, you reinvest at 10. IRR says it pays out at 13.1, I reinvest at 13.1. You may not be able to find projects at 13.1, and certainly you're going to find more projects at 10, between 10 and 13.1, or between 10 and infinity, and between 13.1 and infinity, all things being equal. Generally, we reinvest at opportunity cost, and NPV is your better measure. But NPV is very difficult to explain to a non-financial manager. Net present value should be used to choose between mutually exclusive projects, not IRR. IRR is what we tend to lean on to explain it, because it's easier to explain. NPV is what we should be using to make the decision. Because our job is to do what? Maximize economic profit, create economic profit, create wealth. You can have a situation, and this is one of the situations where IRRs are a little screwy. You can have a situation where a project has multiple IRRs. It'll have one NPV, but it'll have multiple IRRs. So let's assume for a moment you've got a project where you pay out $1,600 or $1.6 million in year zero. You get $10 million back in year one, and you have to pay out $10 million in year two. Would you ever do this? Maybe. It depends. Well, yeah, it's not necessarily what year three looks like. It's actually what return do you get in between space to space. It might make that $10 million worth paying $10 million out the following year because you got interest on it. It needs to exceed $1.6 million plus the discount rate. So you've got the NPV on this project, depending on what IRR you use, can be negative or positive. And so essentially your net present value is negative until you get to an IRR of 25%. Because in that year two, you're going, okay, I'm going to get 25% required rate of return on my money. So I'm discounting back that first year, I'm discounting the second year, I'm discounting the third year, and it comes out positive because I'm making money on that $10 million for that 1 year before I have to pay $10 million back. Right? You follow? So I said it depends. Over time, It goes up, so the IRR equals 400,000. If you find something with IRR 400,000, I'd appreciate you coming to my office hours, because I like to talk to you about it. And at that point, it starts to slip off again. Because essentially what you've got is a situation where the net present value starts to decline over time. At the 400% required rate of return, that first cash flow becomes really large, and that second cash flow is discounted so far that it can't make up for the fact that that first cash flow is discounted so much less. So IRR can get a little screwy. You can have multiple IRRs on a project depending on what the cash flow stream looks like. So what we've created in finance, and you will find in Excel, is a function called modified internal rate of return, MIRR. And what the modified internal rate of return does is essentially says, instead of reinvesting the cash flow at the internal rate of return, we're going to reinvest it at the required rate of return, and then come up with what that percentage is. And the MIRR rule says a project is acceptable if the modified internal rate of return is greater than the required rate of return. And where you can have a situation like we talked about previously, where the net present value says do it and the IRR says don't, or vice versa. In this particular case, the modified internal rate of return and NPV are always going to be the same. They're going to give you the same answer. They're going to tell you to proceed or not to proceed. You're not going to get any dissonance between the two measures. So, yes, sir.
So for the Merkle, it's not greater than 42. It's
Greater than. You can make an argument for equal to, but you're getting no economic wealth created. The next capital budgeting thing is something you hear all the time from non-financial stakeholders called payback. So if I invest $1 million, how quickly can I get that $1 million back? That does not factor in risk. It doesn't factor in length of time generally, although you'll see the payback period says, okay, you'll get it back in 2.5 years, but you're not discounting based on opportunity cost. You're not factoring in any of the risk associated with inflation, liquidity, maturity, default. But this payback period, I want my money back faster because we perceive that getting my money back faster is less risky. So the payback period is here just prior to the year of full recovery of initial investment. Essentially what we do is we take the amount of money that goes out, we take the stream of cash flow that comes in, and we figure out when we're going to get our initial money back. The payback decision rule is the project is acceptable if the payback is faster than some arbitrary number that we came up with. So you're not looking at a required rate of return. You're not looking at anything other than, well, we don't want to have that money out there longer than 4 years. So if the payback's less than 4 years, we'll do it. If the payback's more than 4 years, we won't, even though there's no factoring in of the risk. You can have a really fast payback on a project, like a lottery ticket's got a really fast payback, but there's no risk factored in, and the risk of default on a lottery ticket's pretty high, or the risk of not cashing in is pretty high. But the payback is really quick, seconds. So, I mean, that's the issue with payback is most people understand it. You know, if you give me $1 million, you get that back in 3 years. But it doesn't account for the risk associated with the project at all. It's a way that we financial managers communicate with non-financial managers. It's something that a lot of folks tend to look to, but it really is a faulted risk model. Here's a calculation for Project S. So you've got the cash flows, and we say, okay, we put $3 million or $3,000 out. We got $1,500 back in year one, so we've got $1,500 left out. We get $1,200 back in year two, so we got $300 left out. We get $800 back in year three, so now we're positive. Then we take that difference, 1 year, 2 years, we take this difference, 300 over 800, we assume it's steady. And it comes to 2.4 years. Because that's 0.4. That's how you calculate payback. It's easy. It's almost worthless as a decision-making tool. So like we said, payback doesn't account for time value of money. But this cool concept called discounted payback does. Discounted payback is a length of time it takes for projects discounted cash flows to repay the cost of the investment. And a discounted payback decision rule is a project is acceptable if the discounted payback is less than the project's useful life. So if you're buying a piece of equipment, that piece of equipment's going to last for 5 years. If the discounted payback is less than 5 years, you're okay. If the discounted payback is longer than 5 years, and the reason is line, present value of cash flows, and an interest rate. And so when you've got a stream of cash flows and an interest rate, the interest rate represents the risk and a stream of cash flows represents the time, you're able to then factor in those components that payback doesn't, which is risk, which is time, and discount, and the time as, or money as a time value, and you're able to get to this discounted cash flow model. So the only difference is here you discount this by the required rate of return, you subtract it out, and now the discounted payback is no longer 2.4 years, which was the payback. The discounted payback is 3.2 years. It's the same methodology in the calculation, except instead of just saying, I'm subtracting 1,500 here and 1,200 here, you're taking the discounted value of each of those, subtracting it to come up with the same number. Capital budgeting is used all the time. This is, as we've talked about, the same methodology used to value bonds. It's the same methodology used to value preferred stock. It's the same methodology you use to value common stock. It's just got a little bit different feel because we're looking at a fixed point in time and generally a capital asset. Capital budgeting has become sophisticated. Every time we run into a problem, we create a new thing. So payback doesn't really work well. We come up with this kind of payback. Internal rate of return doesn't work well. We come up with modified internal rate of return. And most companies look at all those factors to try and come up with a decision and see if there's anything that's an anomaly. Are there any questions? I know I kind of moved through this one relatively quickly and I was late, for which I apologize again. Any questions on this stuff? Okay, have yourself a good weekend. I will see you Monday morning. Next week is another short week because of Good Friday. The following week is another short week because of Easter Monday, no classes. So welcome to Catholic school, where you get St. Benedict's Day, Good Friday, Easter Monday off.